actually we're building parts for the collet closer, and this is going to be a 1/2 inch round turn down on this end of it for 3/4 or 7/8 of an inch. It's going to go through a 5/8 inch piece of flat stock, and it's going to be a pivot point for the collet closer. We'll start our cut right there and zero that. Now we've got a respectable finish, although I'm still considering this a roughing cut here. And you can see where I rounded up on the edge. It chatters like crazy there. Part of that's the rigidity of the machine, or the wear in the machine will do that. Most of this is going to be machined away. There's going to be a 3/4 inch, just over 3/4 inch hole bored across through there, and then I'll go ahead and relieve the sides down so it's 3/4 of an inch thick. This started out as 1.25 inch stock, I believe is what it was, with a piece 3 inches long. It's stock I had on hand, so I chose to use it. That's a 50 thou depth of cut, and that's too much for this setup. I can feel it starting to drag. Let's back that off to about 30, I think. We could probably get a little more than 30 out of it. It'd probably be all right with 40 thou, but let's run it at 30 and see how it acts. work just fine. Well, there's our little turn boss on there. A little bit of polishing on the bottom. I left that a little bit too rough, but that's alright, it doesn't make a bit of difference. And our E-clip snaps in there. That'll be our retention for into the bottom piece there. So let's take it over to the mill and bore a hole. Well, I've been a little bit remiss in showing the machining on this. Now this is a pin that we previously turned. This will sit down through the guard. I have gone ahead and I haven't finished this out, but this is the bracket that I've made for it. And the way this will sit is, if this was on the back of the lathe, the headstock and everything is over here, this guard comes out this way. So then this bracket will sit down over the top at whatever the appropriate height is, and it'll get tightened down with a grub screw once it's in position. And then the arm for the collet closer has the 3/4 inch round piece that goes through here, and we pivot our closer this way. So to mount that, I built this little bracket. It will set in there, allow the proper amount of turning there. This is the bushing that I had that I wasn't sure where it went originally. I'm going to go ahead and mount it in there. I boarded it. It does slide in there. I haven't decided yet, but I may very well drill and tap this and this for grease zerks, just because I can and I'm there. They're out there in the open. They'll get virtually nowhere, but a little bit of grease won't hurt. So we may very well do that. But anyway, there's the progress for right now. I'm not going to show the rest of the machining of these parts for them, I don't think. I'm going to take and this part's done unless I drill and tap it for a grease zerk, which will just be an 1/8 inch pipe is what will go in there. This pin, once I figure out how long it actually needs to be, what I will probably do is go ahead and turn it on down this way, and then if I have enough material as it goes through, I'll probably thread that for a nut on the bottom to keep everything captive, so that the guard hinges will be trapped in between there. And then we'll round the top edge and we'll leave whatever material we need for that. And this part I'm going to take back over to the mill, and I'm going to radius the top edge of this, and then we'll just round these a little bit so it's a little more aesthetically pleasing. Kind of clean them up. We'll do some handwork on there to make them look nice and pretty, and then we'll sandblast them and powder coat them up, and then be ready for the assembly of that. So we'll get that done, and then we'll bring you back when we start fitting it to the lathe again. Alright, well, here's the collet closer mounting brackets. I still have not built a draw tube. The 4130 I had did not have enough material to, I felt, comfortably thread the internal dimensions for the collets. So I got a piece of DOM tubing, drawn over mandrel tubing here. It came in Friday, I picked it up. And I'll start turning it here before too long. This is our collet closer brackets set up. I'm still going to make a couple of modifications. It's got a little bit of movement in it, which in the big picture won't make any difference, but I think I'm going to address it. I'm going to do a couple of things on the shaft going down through. I'm going to thread the bottom of it. We'll put a nylock on there, washer and nylock, just to kind of close up those tolerances, even though this guard bottom will have to swing out of the way to open and close. Well, we'll still go ahead and do that. That will take up a little bit of that play, I think. If it's still an issue and I want to address it, why, I'll run a bracket either off of this bracket into the top portion of the guard, which will be stationary, and I have to build the mounting brackets for it. Probably my plan was originally off of this guard position here. We'll run a little Z angle down. That's what I kind of decided to do there. I'm going to go ahead and leave it like this for right now until I get the adapter built for the collets themselves to go in the spindle nose and the draw tube done. So I've got it pretty well finalized. Then we'll go back and we'll probably powder coat everything and get it ready to go. part of the bracketry I'll go ahead and blue up, but I think this pivot and this mounting bracket will probably look a little bit better if they're powder coated. They'll just match the rest of the machine. So we'll do that. Collet closer. There's operation forward, or there's locked position. There's unlocked so that we can change our workpiece out. And when we look at the spindle noses, I look at the drawbar that's still installed in it. Why, when we move it to that position to release it, it does release that drawbar. It goes forward just a little bit. So it's doing what it's supposed to do. There'll still be adjustments in it. It acts like it locks up fairly well, and we can adjust the amount of locking engagement we get on it. But it snaps the position forward and reverse. So what I ended up and did, my mounting bracket, I went ahead and threaded it back up a little bit. I still need to add a little bit of a relief so it sits down tighter on there. We went ahead and rounded the top of that, and we've got material sticking out the bottom, so we can go back and thread that for a appropriate size nylock nut on there. This was our pivot position. It goes down on the bottom through this stud, and there's a snap ring on the bottom of that to keep it from coming out. This has been bored big enough that I used the little bronze bushing that was with the collet closer assembly when I got it. It's a sliding fit inside of there. And I'm going to add a couple of grease zerks on here just to grease it, since we have grease zerks up here on the vertical countershaft assembly. Anyway, we'll go ahead and put a couple of grease zerks on there. It won't take anything to keep it lubed, but since I'm doing it, we may as well add lubricant positions there. So that pretty much, for the moment, takes care of the collet closer. The guard I'm going to split down along here, and I'll set the camera down in a minute and just show a couple of pictures of where I think I'm going to split it, and I'll lay it out and mark it, and then we'll look at it for a little bit before we actually split this guard to make sure we've got it in a position to where it'll open and close. The next thing is going to be, I'm going to disassemble the headstock assembly, and the spindle I'm going to pull out. It's going to get set up in the Sheldon lathe, and we'll use the spindle itself to fit our collet adapter into, and then bore that collet adapter so it accepts our 3C collets. I've got some material over there to turn the collet adapter. I may turn a blank for both. I may turn 2 blanks. So if I do later on add a 3AT collet system, why, we can go ahead and have the adapter for that already ready to go. But we'll go ahead and pull the spindle out, cut our Morris taper on our stock for our collet or for our spindle adapter. We'll fit that to the spindle adapter so we get our tapers right on that, and then we'll set up the spindle in the lathe with the adapter in it. We're going to index that adapter up into a single position, and it'll be retained in one position. There'll be some sort of an index pin or something to guide that in, so it indexes up the same way each time we put that adapter in, although for this application it's probably never going to come out. The only thing I will change is the collets themselves, and then we'll go ahead and bore those adapters, or that adapter, for our 3C collets, and that way we can fit them up, and then it should be concentric with the world when we reassemble it. Why, depending on condition of our headstock bearings, why, that unit or the spindle unit will be concentric all the way around. One thing I do notice on our favorite little auction site is somebody is selling new Morris taper collet closers, or a collet system, so that you can add it right onto your Atlas lathe, and it'll accept the standard Morris taper collet. If you're going to get the most versatility out of your machine, that's a bad system, for the simple reason that while it will accept your Morris taper sockets, then you can go to 3/4 inch diameters, or that's what they're offering, is up to 3/4 inch diameter. What you're losing is to be able to feed it through in a production manner, or through a draw tube, because the Morris tapers are threaded in the back of them, so you're going to use a drawbar like is on this original closer, rather than having a draw tube on it. So you're not going to be able to run longer stock through your headstock and have it supported as you would in a production machine where you want to feed it on through and continuously make parts. You're only going to be able to take a certain length of material, put it in that Morris taper collet, and use it in that manner. So just something to be aware of when you do that. And we're probably just about to end this here. I will show you some pictures of how I laid out the guard of how I think I'm going to split it so it opens and closes. So if you find these videos helpful and not too controversial, why, you might hit that subscribe button if you haven't already. If you hit the bell notification, you'll know when I put out a new video, and any comments or suggestions, leave them in the comment section for me below. And thanks for taking the time to watch. Alright, this is approximately the way we're going to split this guard, I think. We're going to run our line right across here. We'll angle it up a little bit and then straight across the top of the guard. The reason for it is we have to stay above our hinge point here, because that's where it hinges, obviously. We need to come straight across, and we have to clear our adjustments here, and to get a little more guard and a little more clearance while we've angled it up, but we still have to stay low enough to where when it swings open it will clear this. I'm not sure if that'll be an issue here or not, but I think the best way to do it is we'll just angle it up a little bit and right across, and I think that'll give us plenty of clearance. So that's the plan. We'll finish mounting the collet closer, get the adapters built, and get our draw tube built, so we've pretty much got final fit on the collet closer itself before we make the final cuts on that guard. And then we'll just smooth it out, see how it looks, and of course we'll go back and repowder coat it and make it all nice and shiny again.